Hey, what's going on, man? Hey, we're starting our 2.1 Polynomial Review and Factoring. There's going to be a two-part video. The first part is introducing some terms that you guys have clearly seen before. And the next part will actually go more into factoring techniques. Big part of the whole unit, big part of the rest of the year. So you want to go ahead and get this down. There'll actually be a third video, which I'll explain when you get to the third video of the way to organize your strategies to solving this thing, okay? So with that being said, listen, I really want you to do well on this unit because the whole semester predicates off of it, okay? So let's go ahead and get started. All right, first I want to start with a few terms. The first term I want to give you is a monomial. All right, and a monomial is a number or a product of numbers, all right, and variables with whole number exponents. All right, so for example, we can say something like 2a. All right, that's a monomial. All right, again, it's a number or a product of numbers and variables. So 2a would be a monomial. All right, another example could be like 4a squared. That's a monomial, the product of two numbers and variables. All right, heck, you can even say 7. 7 is a monomial. All right, it's a number or a product of numbers. So this one satisfies a number. It could just be a single standing variable like a or x. All right. So again, man, several different ways to look at it. Or true, you can even say something like 4xy squared z cubed. All right. This is a monomial. Again, it's the product. Product meaning multiply. The product of numbers and variables. Okay, so all these are examples of monomials. All right. Our next term we have is going to be polynomial. Okay. A polynomial is a monomial or a sum or difference of monomials. All right. Each monomial in a polynomial is a term, okay? So again, a polynomial is a monomial or a sum or difference, which means add or subtract. The sum or difference of monomials. So if you take those examples of monomials I had here a second ago, and you were to add or subtract them, that becomes a polynomial because it's the sum or difference of those monomials. All right? Each monomial in a polynomial is called a term. So let's say you had a polynomial written out, right? Like 2x squared plus 4xy plus 2. All right. These are the sum. These are the sum. As a matter of fact, just for the sake of showing you, I'm gonna go. Well, that's fine. Minus 4z. Okay. These are the sum and differences. All right, of different monomials. So that's what makes it a polynomial. Okay. Now, polynomials are characteristics of polynomials. Okay. So again, characteristics of a polynomial. There are no variables in the exponents. All right. There are no variables. So you won't see anything like 2 to the x. All right. That's not a polynomial. Okay. All right. It will have to be a whole number like 2x squared. All right. Something like this. All right. Again, you won't see anything like 2x to the y. All right. No variables in the denominator. All right. And if it was a fraction, there would be no variables in the denominator. All right. Meaning something like 2x over y. All right. That's not a polynomial, okay? No variables in the denominator at all, okay? All right. The next thing, there are no roots, which means no roots. We just did this whole unit over roots. There's no roots, no radical, no cube root, no fourth root, fifth root, whatever. All right. Or absolute values. Now, if you remember absolute value, like if you had the absolute value of -4 would be 4. there are no absolute values of variables, meaning there's no absolute value of x, in a polynomial. And all the variables are whole numbers. Excuse me, all the variables have whole number exponents. Whole number exponents, meaning 4x to the 7th would be part of a polynomial. Something like 4x to the 0.3 is not in a part of a polynomial. Or something like 4x to the 1/2 is not part of a polynomial. Because again, it has to be a whole number. 1/2, that's a fraction, it's not a whole number. 0.3 is a decimal, it's not a whole number. You want whole numbers. So take a look right here. And let's see. As a circle, each example, that is a polynomial. Draw an x over each example. That is not a polynomial. So ask yourself, 3x to the 4th, does that fit this characteristic up here? So it's a combination of variables and a whole number, right? There's no, the exponent is the whole number. See, the exponent is a whole number. So this is a polynomial. Now this one right here, see how this is 0.75? Remember, all variables have whole number exponents. Well, this is 0.75, that's not a whole number. So guys, this is not a polynomial. Right here, I got 1/2 a to the 7th. 1/2, that's a number, that's fine. A to the 7th, the variable is fine with the whole number exponent. So this is a polynomial. There's no restriction right here. Right here we have the absolute value. Remember, no roots or absolute value of variables, so not acceptable. Right here we have 0.15. 0.15. That's a whole number, x to the 101. That's fine. There's no restriction right here whatsoever. Now look at this one, 3 to the x. 3 to the x. Remember, no variables in the exponent. No variables in the exponent. So that one right here, no variables in the denominator. Right here, no roots. Here's a root. Here, the variables are fine. They're whole numbers. Everything's fine on this one and on this one. So all those are polynomials. Everything else is not okay. Now we got another one, right? This one, the degree of a monomial is the sum of exponents of the variables. So the degree, that's just that. Like for example, this one, this is 6, so the degree is 6. Again, the degree of a monomial is the sum of the exponents of the variable. So now look at this one. Look at the variables, look at the degrees. A has a degree of 2, B has a degree of 1. So the degree of this entire polynomial is 2 plus 1, 3. The degree is 3. So now identify the degree of the monomial. For this one, x to the 21st, the degree is 21. For this one, again, just like this problem here, you got to look at the variables and add the degrees. So here I have 3 and 2. 3 plus 2 is 5. For this one, there's no variable. Remember, it's the sum of the exponents of the variables. No variables, so the degree is 0. The degree is 0. Here we have 6, 7, B is 1, so 6, 7, 8, 9. So the degree is 9, Now some more fill in the blank. The degree of a polynomial. Now these are monomials, Monomial. The degree of a polynomial, is the degree of the first term given, given, which means, given that, it is written in standard form. Standard form. A standard form is when the terms are written in descending order by degree. All right, so you would write them in descending order like this. All right, see how, again, this is standard form because see the degree here is 3, the degree here is 2, the degree here is 1, and the degree here there's no variable, so the degree is 0. All right, so the degree of a polynomial will be 3 because again, if you list them in descending order from greatest degree to the least degree, 3 is the highest degree. All right, so guys, it's the largest degree. All right, largest degree. Now, if you write it in descending order, then it's always the first one. All right, but it's the largest degree. All right, and then the leading coefficient, guys, is the coefficient of the first term. But once you put this in descending order, all right, here's the largest degree right here, 3. So the coefficient that goes along with the largest degree, so this is 5x cubed. That 5 is the leading coefficient. All right. All right, what does it mean to factor, guys? All right, what does it mean to factor? All right, well, to write it as a product, which means write it as a multiplication problem. All right. So, you need to find the greatest common factor, or the GCF. All right, the GCF. So always look for the greatest common factor first. Always look for the greatest common factor first. Okay, so right here between 4 and 18. All right, what would be the greatest common factor? Well, the factors of 4 are 2 and 2. The factors of 18, there's 4 and 6. 3 and 6, 2 and 9. All right, 1 and 18. But anyway, the greatest common factor right here is 2. All right, GCF. Right here, all right, the greatest common factor between 6, 12, and 54 is going to be 6. All right, 6. Actually, yeah, 6. 6. The greatest common factor right here between 9, 36, and 90 is going to be 9. All right, 9 is the greatest common factor. All right. And again, man, some of you guys may actually have to write this out. Like, take this. If you went 9, what are the factors of 9? All right, 1 and 9, 3 and 3. All right, and then if you go 36, you got 1 and 36, 2 and 18, 3 and 12, 4 and 9, right? For 90, you have 1 and 90, 2 and 45, 3 and 30, 5 and 17. Ooh, it's my fault. 18. 5 and 18. 6 and, let's see, 6 and 15, 7, 8, 9, and 10. All right, so you have to actually write these out. Some of you guys are actually gonna have to do this. All right, write them out. Boom. All right, 9 would be the largest one. Okay. That's one way to do it right there. There's also a way to do the GCF in your calculator too, guys, if need be. Matter of fact, I'm just going to show you. Let me show you how to do the GCF in your calculator. So in the calculator, what you would do is you would go math, then go right to the number section. This is just number, guys. And go down right here to 9, where it says GCD. All right, option 9, which is GCD. And that just means instead of greatest common factor, it's greatest common divisor. All right, but if you go to 9, and then you had, let's see, we had 9, comma, 36, comma, 90. All right. Close that and hold on. Oh yeah, you know what? I remember you can only do 2 numbers at a time. That's what it is. So let me delete out 90. You can only do 2 numbers. So you would do it like that. All right. Then do 2 more at a time. So like, find the greatest common divisor. The greatest common factor. So see, the greatest common factor between 9 and 36 is 9. The greatest common factor between 9 and 90 is 9. Alright, so that's how you do that. Okay, so now, let me erase and finish up. Now, right here, the greatest common factor between x squared y and xy, the variables are a little easier because you just look for the least amount of time something appear. So again, you look for the least amount of time something appear, and that's what they have in common. So here I got x squared and here I got x. All right, well, x is going to be the first part, and then y, they both have one y, so y. So xy is the greatest common factor between these two. All right, over here, again, look for the least amount of time something appears. So here I have 1a. All right, I have a squared and I have a cubed. All right, well, a is the smallest one. All right, it appears the least, a. Now b, you got b squared, b to the first, b cubed. B is the smallest one. All right, B is going to be the greatest common factor right there. Okay. So now, let's go look at this first example. This first example says find the GCF, pull it out front, and write it as a product. Well, all right. What does 14? Well, here the problem is 14x plus 21. What does 14x and 21 have in common? All right, the greatest common factor there is probably going to be 7. All right, so if I take out a 7, what's remaining? All right, you have 2x right here. All right, and you have 3 right here. Again, once I factor out a 7, I divide these terms by 7. All right. Over here, all right, the greatest common factor. All right, let's look at the whole numbers first. 5, 10, and 15 is probably going to be 5. And now I look at the variables. I have a single a squared, and a squared. It's probably going to be a. And right here I have b squared, and b. So it's just going to be b. So now divide all these out. If I divide 5 and a from here, I'm left with b squared. If I divide 5 from 10 is 2. Take an a out of this a squared, you're left with 1a. And take a b out of this b squared, you're left with 1b. And take a 5 out of this 15, you're left with 3. Take an a from a squared, you're left with a. And if you take a b from b, guys, there's no more b's, okay? So right here, this is the GCF, okay? Now, I got some U-tries right here for you. All right, now with these U-tries, again, it's just pulling out the GCF, guys. All right, between all of these, and then writing the product, writing it as a product like 7 times 2x plus 3, or 5ab times b squared plus 2ab plus 3a. So give that a try. All right, factoring 2 terms. Always look for the GCF and look for special patterns. All right. The first special pattern, which is really easy to remember, guys, is the difference of 2 squares. All right. Now, first, when you look at it, a squared minus b squared, difference means subtraction. All right. So write this down. Difference means subtraction. All right. That means subtraction. So that's the first thing you look for. Let me write that a little neater. All right, subtraction. All right, of 2 perfect squares. Now, the other part is 2 perfect squares. All right, if you have 2 perfect squares, all right, and there's a difference in the middle, so it's a perfect square minus a perfect square, what you do is you take the square root of the first term, all right, and you take the square root of the second term, and your middle is going to be plus or minus. And I'm just going to show you an example. All right, I'm going to take 2 perfect squares. Like, let's say 4x squared. All right, that's a perfect square. X squared is a perfect square because it's squared. All right, minus 9. Okay, both of these are perfect squares. 9 is a perfect square. 4x squared is a perfect square. So if I were to take the square root of this, I'll have 2a, right? Because 2 squared is, oh, not 2a, I'm sorry. Man, 2x, sorry. 2 is a perfect square. 2 squared is 4. x squared, right? If I add x times x, I'd have x squared. All right. And over here, the 9, all right, the square root of 9 is 3. All right. So if I take this first term, 4x squared, and take the square root 2x, all right, and then take the second term, take the square root, which is 3. All right, I'm going to take those terms, and I'm going to write them twice, all right, and I'm going to put a plus or minus in the middle. So I'll have the answer to this, 2x squared minus 3. If I factor it, would be 2x plus 3 and 2x minus 3. All right, 2x plus 3, 2x minus 3 again. All right, factor this to get 2x, factor that to get 3, and also there's a minus in the middle, the difference of two squares. All right, and that's what you have. So for this first one, we look at example 3. I want you to look, 18 is not a perfect square. All right, 50 is not a perfect square. But if I take out the GCF, remember we just did the GCF? Let's factor out the GCF. I have 2 times 18 divided by 2 is 9. And negative 50 divided by 2 is negative 25. All right. So now take a look at it. 9 is a perfect square, so is x squared. 25 is a perfect square. All right. So now with this section right here, I can apply the difference of two squares with this part. All right. So now don't forget your 2. We're going to come out to that. But this, if I apply the same logic we just used up here, all right, the square root of 9 is 3. The square root of 25 is 5. So what you get is 2, right? That's outside. See how that's outside? Now, apply the perfect square concept that I just talked about. All right, you're going to write those square roots twice. 3, see is the difference? So 3 plus, or I'm sorry, 3x plus 5 and 3x minus 5. All right, that's the difference. See the subtraction? That's the difference of two perfect squares. So 3x plus 5, 3x minus 5, but then bring the 2. So the answer to 18x squared minus 50 is 2 times 3x plus 5 and 3x minus 5. All right. Now, right here, I know you guys often forget, so I'm going to just show you. 1 times 1 is 1. 1 is a perfect square. 1 squared is 1. All right. So 1 is a perfect square. The square root of that is still 1. 16 is a perfect square. The square root of that is 4. And so is y. Y squared, since it's squared, it is a perfect square. The square root of y squared is y. So when you factor this, it's the difference. You see the difference? So you have 1 plus 4y. Oops. Thinking ahead of myself. 1 plus 4y. And you have 1 minus 4y. All right. This right here, guys, is the difference of these two squares. So there's a you try right here. You try that, okay? Give that a try. All right. The sum of two perfect squares. The sum of two perfect squares. All right. Right here, I want to show you something. You do the exact same thing, except you're going to have eyes. And the reason you have eyes is because of this. See how this is positive and this is negative? A positive times a negative, if I were to FOIL those, will give me a negative, right? A negative b squared. But that I times I is I squared. Well, remember, I squared equals negative 1. So if you have negative 1 times a negative, then it becomes positive b squared, okay? So I'm just saying that so you understand that you do it the exact same way, but you remember that you have to have the eyes, okay? So look at this first one. 4 is a perfect square, m squared is a perfect square, and so is 81. But again, this is the sum. All right, not the difference, it's the sum. So you're going to have I in your answer. So the square root of 4m squared is 2m, and the square root of 9, of course, is 81 is 9. All right, but don't forget your I. So what you have is 2m plus 2m plus 9i and 2m minus 9i. Just like that, okay? All right. Exact same steps. You just got to include your I, okay? Over here, all right, first of all, 98 is not a perfect square, and nor is 32. So I'm going to go, what can I divide this by to have a perfect square? All right, I think 2. Okay, so if we factor out a GCF of 2, and we do 98 divided by 2, that's 49. And 32 divided by 2 is 16. All right. So now, if 49 is a perfect square, the square root of that is 7. 16z is a perfect square. The square root of 16z is going to be 4z. 16z squared, excuse me. It's going to be 4z. All right, and it's the sum. So we have the 2 right here. Then we have the perfect squares, 7 plus 4zi. Don't forget your I on the last term, just like that. Times 7 minus 4zi. Again, do not forget that I, okay? So that's another you try. But I'm going to stop right here, guys. There's some practice right here for you. All right, we'll do that tomorrow in class together. All right, the main thing is try these U-tries. All right, write down any questions you have. Bring those. All right, and you can check them with me tomorrow. All right, give that a try. And, hey, we'll continue this shit rolling, man, on the next video tomorrow, okay? Bring me questions. Don't forget, bring me questions. Have a good evening.